another lesson in pre-calculus. We're going to start a new unit today on polynomials. Our very first lesson will cover operations on polynomials as well as doing some things with factoring and solving. In the past, we've looked at things like this. This is called a monomial. In particular, it's a quadratic. And then you have a binomial with 2 terms, a trinomial with 3 terms, and then you've got something that's even longer than that. I don't really know how to say that. Quintonomial. I don't even know what that would be. But what we're going to focus on today is what a polynomial is, and I'll get into the definition of that in just a minute. First, though, we're going to have in the lessons today something called a pleasant polyprefix, just to help keep you educated with different words that start with poly. So, for example, if you have a guy who is worshiping and praying, and he's worshiping the word the, what do you call that? You call it polytheistic. You see, I'm going to help you understand lots of words with poly, not just things dealing with math. So let's get into our first part of our notes, and that is definitions of a polynomial. Now, I kind of watered this down a bit, just trying to help you understand the basic idea of a polynomial. So there's not a lot to write down except for right here, this part. But what is a polynomial? Basically, it's a bunch of monomials. So here's a term, there's a term, there's a term. So just a bunch of terms that you can add or subtract. But you have to make sure that the exponent is a whole number, meaning that the exponents have to be positive and they can't be decimals. And also that the coefficients must be real. Well, that part's real easy because it just means that these numbers can't be i's. They can't be imaginary. So that's easy enough. They can be decimals in front, though, or irrational numbers, whatever you want. But the exponents must be whole. So I have here a definition of all these things. You should probably know these already, but let's just write down from our example what each of these are. The constant term in this example would be the number 1 from up here. So there's our constant. The degree is the largest exponent of the variable. So you look at all the variables and you're looking for the largest exponent. And in this example, the largest exponent would be right here with a 5. So the degree of this is a 5. The leading coefficient is going to be the coefficient of the degree term. So here's our leading coefficient, but it's not just a 3. Be careful there. It is a -3. So there's my leading coefficient. And then standard form, let's reorder this so that it is in standard form. It would be f of x equals, so we're going to start with the largest exponent, which in this case would be -3x to the 5th. That's also why we call this the leading coefficient, because it would lead the whole thing and be in front if we put it in standard form. And then we count down from there. So the next one will be the x cubed. We go minus 2x cubed plus 8x, and then our constant at the end of a plus 1. And there's your quick introduction to polynomials. Now we'll come back to these things throughout the entire unit. Just want to make sure you have this at the very beginning of our unit to have some notes on that there. Now we'll get into some easy stuff for most of you. In fact, this example number 1, I even paused. I didn't even want to put this in here, but I thought, I better, because for some weird reason, I still get students who think that because this is in parentheses, that means multiplication. Please don't do that. This is addition. It's got addition in between these things. You just have to make sure you add like terms. So the answer to this is 12a cubed. And then let's figure out anything else. The a's, we got to match up a's. So 5a plus a plus 6a. And then match up any constants. And then all you have is the minus 2. So there's your answer for number 1. Number 2, we're subtracting. So the trick here is you need to distribute the negative. Now, some of you really, really like to skip the step of showing that step of distributing the negative. I would recommend that you do not skip showing that step. And the reason is we're going to have enough complicated things going on in our future math career that when you don't show that step, it's very easy to lose track of the negative. So show it. Even if I'm working through things, lots of times I'll show that step for myself just to make sure I don't lose stuff that's going on. It's a bummer to miss a problem just because you've forgot to distribute a negative. Okay, now combine like terms. So we got 3x to the 4th. What's my next largest square? So I got minus 7x squared, and I think the next thing is a constant. So 2 plus 7 is 9. Now here's another weird thing that I keep seeing in pre-calc, as well, algebra 2 as well. I'll get students who get here and think, okay, so now what? I need to factor? No, you don't need to factor. You're done right there. Don't factor unless it says to factor. You're only going to factor if it says factor or if you're trying to solve an equation. This you're just simplifying, so stop right there. All right, next one. Now we will multiply. The big thing with this on multiplying is just try to have some nice methodical manner of distributing. So you take the first term and you distribute to all three. So let's do that first. 7n times n squared is going to be 7n cubed. The next one will be a 42n squared, and then the last part here will be plus 21n. Now realize the only thing I've distributed was the 7n. So now that you're done with that one, we go back and we distribute the 1. So now I'll distribute the 1, the 1, and the 1. So as long as you can keep this nice and organized, it's really not that hard. Plus n squared plus 6n plus 3. So this is just pure distributing all the way through, then take the next term, distribute all the way through, and now combine like terms, and we are done. 7n cubed, let's see the n squared, so we've got a plus 43n squared. Now the n terms get a plus 27n, and then our only constant is the 3, so plus 3. And these are polynomials because you'll notice we have whole number for exponents of the variables and they're real numbers for all of the coefficients. Okay, well, good. Done with number 3. And now it's time for a pleasant polyprefix. What happens when you have a bunch of people with knees that are all over the place, and when you put them all together, people with knees, you get Polynesians. Aren't you glad you're watching this lesson? You're getting so smart with all these cool words. Okay, going on now, we have factoring. We're going to cover 4 types of factoring. Difference of squares, factor by grouping, quadratics with a leading coefficient, and then a quadratic form. Some of this will be nice quick review for you, so we'll go kind of quickly. But I've noticed that some students are still having issues with difference of squares. This really has got to be automatic. Now let me point out as you're writing some of this stuff down here, this a squared minus b squared, that you should probably also write things down in your notes that are not just exactly what we're writing. A lot of times students, we say actually important things. Okay, most of us. Okay, outside of Kelly. The other 3 of us, we really say important things in our lessons, and you probably want to write some of that stuff down. For example, I'm not going to write this down, but these 2 things are called conjugates of each other. Conjugate. And so that would be something that you could write down. I'm going to refer to the conjugate once in a while of these. And let's start off with this one. The first thing you should always do when factoring, always do in factoring, is factor out what they have in common. So on the directions, I didn't write the directions, but the directions should say that we're going to factor these things. So t to the 4th minus 16. These are perfect squares. They will factor to the square root of t to the 4th is t squared, and then the square root of 16 is 4. And then the conjugate of that is going to be t squared plus 4. Now we're not done yet. We've got to go one more step. And that last step is that the t squared minus 4 is also the difference of 2 perfect squares. And so we say t minus 2. The conjugate of that is t plus 2. And then you still have t squared plus 4. You cannot do the sum of squares. Okay, so you don't worry about this last one. That does not factor out. But that would be your final answer right there for factoring. So go ahead and pause the lesson now. Why don't you try number 5 on your own? I'll have the answer appear in just a second. And there's your answer. Notice that I only broke it down one time with its conjugate. I didn't keep going because while 9 is a perfect square, x is not. It's not 9x squared. If it had been, I would have kept going with this subtraction term, but, well, no, because 10 is not a perfect square. Never mind. 10 isn't a perfect square anyway, so I couldn't have gone from there. There's your answer. Okay, make sure our whole goal with this difference of squares is that you don't need to worry about how to factor it. It's just an automatic quick little thing for you. Going on number 6. Now we're going to do factor by grouping. Here's the way this works. Typically, if you have 4 terms, 1, 2, 3, 4, it's going to be pretty tough to factor. And so you try to do factor by grouping, in which you look at the very first two terms and then you look at the last 2 terms. So what do the first 2 terms have in common? let's see, for the numbers, what goes into those numbers? 56 and 49. 7, right? Yeah, 7. Okay, so let's take out a 7, and then they also have a v squared from both of them, so we'll take out a 7v squared. And then we multiply that by, what's left? 8v minus 7. Close the parenthesis. So we factored out the 7v squared from both of these two terms. Now we'll go to the next two terms. What do these both have in common? I believe just a 7, right? Yeah, no, a 6. So we take out a 6, a positive 6, so I say plus 6, open my parentheses, and then what's left is an 8v minus 7. So here's how you know if you did it right. This is what I love about factor by grouping. You can kind of check as you're going, because this and this has to be the same. If it's not, you did it wrong. And sometimes you will have done it wrong because maybe these needed to be reordered. Typically, if you're just in standard form counting down, it'll work out. But if it doesn't, you may have to go back up to this step and reorder some of these things. But then our last step then, okay, watch this down here. What if I had this? 7v squared, let's call it y, plus 6y. Just watch this for a minute. You'll see what I'm doing. And this term are in common. And if you have that, what can you factor out? You factor out the y, 7v squared plus 6. So the y would come to the front of this thing from both of them. That's exactly what we're doing. And up here, instead of a y, it's an 8v minus 7. So our answer becomes, take out that 8v minus 7 to the front, and you are left with 7v squared plus 6. Now it's nice and factored. It doesn't keep going. We don't have any difference of squares here, nothing else, so we can box that, and it is completely factored. So number 7. This one looks kind of crazy. It's really not that bad. I don't have a pause dude next to it, but I'm going to have you pause here. Just do it just like I just did this one. Focus on the first two, factor out what they have in common. Focus on the next two, factor out what they have in common, and I will have the answer appear here, see what you get to. There's your answer to number 7. A little bit complicated on that one. You do not have to keep going here because it is not the difference of squares. These 21 and 18 are not perfect squares. So there you go. A lot of a's squareds, d squareds, and x's all over the place in there. Sorry about that, but not too difficult if you're just really careful as you're going each step. Next we have another pleasant poly prefix. This one involves my wife Esther right here. She's hovering over here, going on a nice little kiddie ride. Actually, okay, not a kiddie ride, but she's enjoying herself. I hope she doesn't get mad that I am doing this. And then all of a sudden she keeps going and she's really not enjoying herself anymore. And now she's really again wishing she hadn't gone on this thing. And again, she's pretty upset. By the time she's getting done, she just wants to be over. So why am I showing you all this? Because if my wife's name is Esther and I have a bunch of pictures of her, then that's considered polyester. There you go. Another new poly word. Next part of our lesson, quadratics. Ax squared minus bx plus c. I'm going to help us with making sure you remember with our leading coefficient, not the number 1. I know you've already covered this, so let's do this real quick, but I'm using factor by grouping for these. I do think this is a good way to factor these. Always look to see if they have something in common. This one might be divisible by 3. Let's see here. 3 goes into 9. 6 and 6 is 12, so it goes into that. 1 plus 0 plus 5 is 6, so 3 can go into this one. Let's do this little trick to see if 3 is divisible or not, and it is. So let's factor out a 3. We get 3r squared minus 22r plus 35, right? 35, 70, 105, yes. Okay, next part. Now the next step, it's going to be 3 times. Now, some of you can just see this, and if you want to, don't write down what I'm doing, but some of you, if you can just go right to 3r times r, you know it's got to be 3r squared, so 3r times r, figure out 35. What multiplies to 35? They're probably both got to be a minus. Some of you can just see it, then go for it, do it. But if you can't see that, and this is confusing, then this is a process, a mathematical process that will help you a bit. And that is, you rewrite the 3r squared here, you don't touch it, and then I'm going to write a 35 at the end of this thing, close my parenthesis, leave enough room to break up this 22. So now what you do on the side is, just kind of on the side of your notes, you think 3 times 35 is 105. So we're going to multiply to 105 and add to negative 22. Let me say that again. Multiplying to the outside, 3 times 105, multiply to 105, add to negative 22. I love Mr. Sullivan's trick on this, and that is if you plug that in saying I want to figure out what goes into 105 evenly, so you do it like this, 105 divided by x, then it's real nice because then you just go straight to your table, second graph, and then you can see, all right, I'm looking for two numbers. They're going to multiply to 105 evenly, so like 5 and 21, but they're going to have to add up to a negative 22. So what is that? Negative 22, 7 and 15. There it is, 7 and 15. So we can come back here, and we put for our answer minus, oops, load my blue, minus 7r minus 15r, and then plus the 35, and then you do factor by grouping.
Let's go to our next step here, and that is that it's going to be 3, because there's 3 on the outside, and we're going to multiply it by a bunch of more stuff here. So on these first two terms, we're doing factor by grouping. What do they have in common? Only an r. So I'm going to take out an r, and then I'm left with 3r minus 7. Close parentheses. What do these next two have in common? A 5, but I need to take out a negative 5 because I want what's left to look like this, 3r minus 7. So if I take out a negative 5, I'm left with a 3r minus 7. Close it all up, and then we have the 3 that's on the outside, and times, what do these both have? 3r minus 7. So let's do 3r minus 7 times r minus 5. Okay, there you go. We're done.
Now that was a lot of work if you weren't able to just see the pattern. Sometimes, again, let me go back to it. Please just do it. If you can see it, you know that 3r times r is going to give you the 3r squared, and then you see the 7 and 5 is going to give you the positive 35, and if you multiply it out, you'll get negative 22. Then just do it. Now we're going on to quadratic form, which is going to be very similar to the quadratics that we did up above. I'll make these examples are going to be a little bit easier than what you'll have in the practice. It's just to give you an idea of what's happening. If you have a negative in front, always take it out. Don't leave a negative in front when you're factoring. It just makes it harder. And in this case, I can also divide by 3, so I'll take out a negative 3. That leaves me with x to the 4th minus 8x squared minus 9. Close my parentheses here, and then you get negative 3 times. Okay, so this is where it's a little bit new for you. It's not too bad, though. Instead of x, if I wanted to get x to the 4th, I need to have x squared in the front of both of these. X squared times x squared will give me x to the 4th. And then I'm going to multiply to a negative 9 and add up to a negative 8. So that is x squared plus 1, x squared minus 9. And then the only thing left to do, because I can keep checking, remember difference of squares here. So then my final answer would be x minus 3, because the difference of squares, and its conjugate, x plus 3, times x squared plus 1. Alright, done with that one. Box around that one. So now why don't you pause and see if you can do number 10. It's going to be similar to number 9, where you're looking for what multiplies to the front and multiplies to the end, adding up to the middle. See what you get. And there's your answer to number 10. You don't have to do anything with, again, difference of squares, because those are not perfect squares. The 5 is not. A squared and b squared are, but that's it. And now it's time for another pleasant polyprefix. You have probably heard of this girl named Pollyanna. She's in some old movies way back when. But have you ever heard of Polysully? Okay, that was weak, but it was still funny. Going on to zero product property. I like to abbreviate this and just say I'm referring to ZPP. Zero product property. What this means is that if you've got A and B equaling 0, it's just real simple. A has got to equal 0, or B has to equal 0. One of them does. Okay, so that's all you're doing with these factoring. You just take these. This is back in our even Algebra 1, Algebra 2 days, so it should be pretty quick and easy. You just say that if you have a variable, remember it's got to have a variable. If you have a variable, then that one has to be 0. Or if you solve this one, you'd have to end up with an x equals 4. You take 2x minus 8 equals 0 and solve it. And again, you take this one, set it equal to 0, solve it. You get x equals negative 5/4. That's the zero product property. The whole idea is make sure it equals 0, use all your factors, and you solve from there. So let's try out number 11 here. We're almost done with our lesson. This is close. First thing is, once it equals a 0, in this case it already does equal 0, then we try to factor everything after it equals 0. Then we'll use the ZPP. That's the whole point of zero product property. So let's just take out, since they all have x squared, let's take that out to the very front. Then what are we left with? X to the third minus x squared plus 3x minus 3, and then that all equals 0. Okay, now we do have some factors here, but I think this can keep factoring. I want to factor as much as possible. So the next thing down would be, since there's 4 terms, I'm thinking here this has got to be factored by grouping. So let's take out, the first thing's going to have another x squared times x minus 1 plus, now these both have a 3 I could take out, so 3, and that's left with x minus 1. Close my parentheses and then close the entire parentheses equals 0. And then notice that you have the same thing here with this x minus 1 and the x minus 1. So then you can jump down to, we have x squared times x minus 1 times x squared plus 3. All right, equals 0. Now you use the ZPP. And why? Because it equals a 0, and you have all of these terms here. So you say that x squared equals 0, or x minus 1 equals 0, or x squared plus 3 equals 0. And when you solve these, you get x equals 0, x equals 1, and this one you're going to end up with x equals plus or minus, because you're going to take the square root of both sides. You'll have a negative 3 over here, so that means it's I, for imaginary, square root of 3. Yes, we are doing imaginary roots as well as real roots. Okay, so there is our answers for number 11. So try number 12, and there is a little trick to number 12, so if you get stuck on it, go ahead and just unpause the video here. But try this one out on your own. Okay, look at this crazy answer. I'm so sorry to do this to you on your own, but the idea was for you to discover this does not factor, but that doesn't mean you stop. Just because it doesn't factor doesn't mean there's not a solution. There is an imaginary solution on this, and you got to use the quadratic formula to get our exact answers, and plus they're imaginary. So, and if you don't remember the quadratic formula for this particular piece, you use that, of course, when you have a quadratic that equals 0, and that is this. So remember, there's a little song, if you don't remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You know, Pop Goes the Weasel. So you've got to know this thing, all right? I'm not putting this on a mastery check and test. You just need to know the quadratic formula and when you use it. This is something that might be good for the side of your notes. Put that on the side of your notes, or even also write, you use this when a quadratic expression equals 0. That's when you use it. All right, so there's your answer for that one. Pause and get this written down if you don't have that, because our final part of our lesson is one last pleasant poly prefix, and this one is going to be something that's about polydactyl. Polydactyl this is actually real. I'm not making a joke on this one. It's about when you have more than the normal number of digits on your toes or on your fingers. Just a funny little clip about somebody who had that, and that's it for our lesson. So rock that mastery check, and I will see you back in the next lesson.
I do not mean to pry, but you don't by any chance happen to have 6 fingers on your right hand?
Do you always begin conversations this way?
My father was slaughtered by a 6-fingered man. I love my father, so naturally I challenged his murderer to a duel. I failed.
How old were you?
I was 11 years old. When I was strong enough, I dedicated my life to the study of fencing. So the next time we meet, I will not fail. I will go up to the 6-fingered man and say, hello. My name is Inigo Montoya. You killed my father. Prepare to die.
Well, I certainly hope you find him someday.
Hello. My name is Inigo Montoya. You killed my father. Prepare to die.